Hey there, freshmen. This is Mr. Pickett, and what we're going to be talking about today is interference with waves. And as we're talking about waves, we could be talking about electromagnetic waves, which would be your visible light, your infrared, your ultraviolet, your X-rays, anything like that. We could also be talking about sound waves, and we could also be talking about um, waves that are running through water. So there's all sorts of things that occur when waves interact with things. And so three of those we know a little bit better. The top three, reflection, refraction, and diffraction, are things that we've learned about in class before, so we'll do a quick recap of that. But the other two are probably things that you haven't thought about or you haven't seen for a little bit. Those are constructive and destructive interference. So with reflection, we can think about some sort of a wave that's generated and it's moving towards a barrier, and it strikes the barrier and it's going to literally bounce off of that barrier. And there's a certain law of reflection. Basically, it says whatever angle that it bounces in, it will bounce out. And then we have this idea about refraction, where some waves, instead of bouncing off of some sort of a barrier, they'll actually go through. And so this wave of, we're assuming it's probably infrared or some sort of an electromagnetic wave, is traveling maybe through air, and then it hits a pocket of something different. Maybe it's going to be traveling through space, which is a completely different medium, which this would make sense. And what it's going to do is it's actually going to go through, but it's going to change directions. That's refraction. So reflection, it bounces off at the same angle, and refraction, it goes through, but it changes directions. Then we had this idea about diffraction, and so this object up here, I'm really not sure what it is. It could be a lot of different things. Is emitting some sort of wave, and that wave is traveling, and as it gets through some sort of a point or an area, what it's going to do is it's going to actually, oh, cool, that's a nice little piece on there. But as it goes through this spot, what it's going to do is it's going to have the wave actually take up as much space as it possibly can. It allows the wave to fill space, basically. And that's an easy way to think about diffraction. Now, as we dig into this a little bit more, here's a good picture of kind of constructive and destructive interference. So we can think about two waves that are in phase. That would be the blue and the green wave. They're in phase with each other. We can see that their troughs line up, their crests line up and their troughs line up as well. And as a result, when these two waves are actually in sync or in phase with each other, they could combine in this situation. And when they combine, they're actually going to make their wave's amplitude, and that's what this red thing is, higher. It's going to be adding these two together to create this. Oop. Just like the troughs will do the same thing. And when they're all at zero, they're all at zero. Now with destructive interference, we're going to notice that the red line is no longer up or down. It's completely straight across. The reason that's happening is because we're still going to combine these waves. So we'll combine green and blue, but we'll notice when we add these two together, they're equal and opposite. And so it's kind of like adding +4 and -4 together, we'll end up getting 0. And so destructive interference has the ability to basically take a wave and make it appear like it's not there, and constructive interference can make a wave appear like it's really, really big, or waves appear that they're really big. So if you go back to that introductory video where we were having waves that were doubling up, that is a great example of constructive and destructive interference. And so the wakeboarders actually had to make sure that they hit the wave at the right time, because they had to wait for, I think they called them rollers, and the wake of the boat to actually hit each other, because sometimes they would get a wave that looked like this, and other times we would get waves that were destroyed, basically, and they would be almost non-existent. So I have kind of a way to look at this as well. So let's imagine here's our wave, and then here's our other wave. If we think about them as being in phase, they're right on top of each other, right? So if they're on top of each other, they're actually going to add to each other. So this wave would actually peak up here, and its bottom peak or its trough would go down here as well. If they were starting to get out of phase, like maybe this, what would happen is if this wave and this wave combined, they would actually create no wave, right? And we get them in phase again. So just kind of a visual, kind of a cool way to think about constructive and destructive interference. We also want you guys to think about another way to look at constructive and destructive interference. So this is a famous experiment called the double slit experiment. So what we're going to see is we're going to see basically a wall, and a wall is probably not the right term, but some sort of a barrier that's got two small openings that we call slits, and then we have some sort of a screen on the back. What's going to happen is we're going to send light or any other type of wave through. These are going to represent the waves of light, and they're going to get through this opening. Now, you would expect that with these two openings, especially if you had like a ray of light or some sort of a light source here, that you would get a really bright spot here, and nothing else. That's what most people would expect. So what happens is as these waves of light get through, we end up creating their own little kind of wave patterns. And so if we center it right here, this is going to have its really cool wave pattern. Think about it like I drop a pebble in a pond. Yes, this is what it's going to look like. We also have to add in this one. And wow, all of a sudden, we get this cool little cross-hatching pattern that exists. And if we're a little bit more specific, when we see these waves actually hit each other, it's basically a double up. So we'll get really, really bright light. And then when we have these places specifically in the middle of these kind of weird little quadrilaterals, I think that's the best way to describe it. Those are places where we basically get no light. So we get these really bright spots, and then we get places where we get really, really almost no light. And so we can see with this pattern that we're going to have a super, 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 super bright spot here and here and here. And you can see all those as well. And then you're going to get places where it's a lot duller. And here is maybe a better physical representation of the famous double slit experiment. All right, I hope you guys learned something today about constructive and destructive interference, and also reviewed diffraction, refraction, and reflection.